So this is. So here, a random sample of 100 students gave a mean weight of 58 kgs with standard deviation 4 kgs. Test the hypothesis. The mean weight in the population is 60 kgs. What is given under the null hypothesis? The mean is mu equal to 60. So in order to prove that the sample of 100 students whose mean weight is 100 students mean weight is 58 kgs and standard deviation is 4 kgs. But the mean weight of the population, so means total population weight is also given. That is mean means mu equal to 60. H1 equal to population mean weight is mu not equal to mu naught. Here they have given mu equal to mu naught. Need to prove. Okay. So that is. So complementary hypothesis is mu not equal to mu naught. So we need to test alpha equal to 0.05. Our test statistics for single mean is what? Z equal to x bar minus mu divided by sigma by root n. So here, given the values what x bar, where small n equal to 100, where small n equal to small n to 100. What is sample mean? Sample standard deviation is also given. What? 4 kgs. Okay, 4 kgs. So then here, to substitute the values where sigma in large sample there is a formula where sigma equal to yes. Sample standard deviation is equal to 4. So that's why this is x bar. This is population mean mu equal to 60 and sample mean x bar equal to 58 and sigma is 4 by 100. So this value will substitute, we will get the minus 5. So modulus it is 5. So calculated value is 5. So tabular value 5% level of significance is what? 1.96. Okay. Calculated value is greater than tabular value. So we reject H naught. The population mean is not equal to 60 kgs. So next one is a sample of 50 students which mean weight is 67.47. So can it be reasonably regarded as sample from a large population with mean weight 67.39 inches with a standard deviation 1.2 inches? Same problem here. What is given? Sample size n equal to 50 and mean weight is what? Mean weight is what? X bar equal to 7.47, where population mean weight is what? 67.39. So here, when substitute the value in the formula, the sample mean and population mean. Sample mean is given, population mean here. So then what we get the value? 0.0474. So that means what? Which is two-sided test mu not equal to mu naught. So 5% level of significant value is 0.96. So calculated value is less than tabular value, then H naught. We cannot reject means accept H naught. Accept H naught. The sample, the population mean of weight is 67.39 is confirmed. So next one is test for as I yesterday formula the test for proportion. So test for proportion. So what does mean proportion? Proportion nothing but x by n. Observations out of n observation from out x observed values. So which one follows Bernoulli population with probability success is P. So our alternative hypothesis is P greater than P naught, P less than P naught, P not equal to P naught. Here the level of significance is alpha. So here, based on a random sample size n taken from above population in a large sample proportion P equal to x by n. Here x is the number of success from the observed sample. So P is the sample proportion, which mean is P. So variance is PQ by n. So where z equal to x bar minus expectation of x by sigma by root n. So here that sample proportion is P, population proportion is P naught, under root of standard error is what? PQ by n. Okay. So that is in normal distribution minus delta by 2 alpha by 2. So which is, this is a normal distribution table. So here alternative two-sided P naught equal to P naught. So since normal distribution is symmetric, the two regions are divided into alpha by 2. So if we have large positive the value, small of negative values of the value Z under H naught, that actually goes in favor of the alternative. If the data really supports H naught, we accept a value close to 0. So we do not reject H naught. So otherwise the test static follows and is the calculated value Z less than tablet value is accept H naught, otherwise reject H naught. Okay. So this is left side value, this is left tail, this is right tail. So here the same one problem. A manufacturer of laptops claim that 60% of people use laptops of their company. In a sample of 40 people, 19 are using laptops of the company. Is a claim of the manufacturer valid? So that is, so what is given? 60% of the people, they in laptop that 60% of the people use laptops of their company. In a sample of 40 people, 19 are using laptops of the company. So is a claim of manufacturer is valid. So what is manufacturer actually claims 60% of the laptops are whatever laptops in the company, 60% of the one brand. Okay? So the manufacturer claims whatever using the laptop are 19 40 people, those are that company only. So how we have to is population P equal to 60% is 0.6. So the population, the aim of the manufacturer is not valid. So that is less than P. So here this statistic get statistics is P minus P naught under root of PQ by N. So here P is X by N. That value is 0.475. Okay. Minus P naught is 0.6. So PQ. P is what? 0.6 minus 1.4. P and Q by N 40. So the value is 1.6137. Okay. So that is under 5%, the value is 1. Which is single tail because P less than P naught. So that's 1.645, the tabulated value. So the calculated value is 16137 is less than 1.6435. So accept H naught. Accept H naught. Accept H naught means the manufacturer, whatever he proposed is true. So 60% of laptops are they, that company only. Okay, accept H naught. So next one is one more problem. Past experience reveals that 5% of the item produced by men are effective. In a sample the 56 items produced by the machine, there are 8 defective items. Can we say that there is deterioration in the performance of that machine? That means, so past experience tells what 5% of the items built by a machine are defective. Overall, the manufacturer claims 5% of there are defective. But in practical, 56 items produced by that machine, they are yet defective items. Can we say that there are is deterioration in the performance that machine? So is that is valid, whatever the manufacturers assume as says, so that we have to. So the proportion is P equal to 5%, 0.05. There is no deterioration in the performance of the machine. No, here this is not no deterioration. 5% of the emission are defective. That is, so our null hypothesis is not defective. Okay, so that is what the population proportion P greater than P naught. So there is a deterioration in the performance of the mission. That is, say there is a deterioration. That is the alternate hypothesis. Our null hypothesis is there is no deterioration. Okay, so P equal to 0.05. Excuse me. Don't make any confusion. So the manufacturer, the company experiences. So one can deal this 5% of the items produced by a machine are defective. Okay. So in a sample of 56 items produced by that machine are 8 defective items. Can we say that there deterioration in the performance of that machine? So that is the population of proportion P equal to 0.05. Okay. The population proportion P is greater than P greater than P naught, where alpha equal to 0.05. So Z equal to P minus P naught under root of standard error. So here P value is 5%. Some P naught is what? 56 items. 8 of 8 items are defective. Means 8 by x by n. X is 9. 9 by 56. Okay. That value is 0.1601. So here substitute small p minus small p minus capital P by PQ by N. So these are the values. So here we got the 0.01. So two test, the left set tail test, whose value is what? So its value is what? 1.6137. This is so this value is 1.645. So calculated value is greater than the tabular value. So there is deterioration in the performance of the machine. So what is that? There is a deterioration in the performance of the machine. So here it is known that 15% of the words used by a writer are of Sanskrit origin. In a sample of 75 words that written that there are 17 words of Sanskrit origin. Can we say that there is a change in the usage of the words of Sanskrit origin? Test the hypothesis at 1% level of significance. So here what our hypothesis is, P equal to 0.15. So means there is no change in the usage of words of Sanskrit origin against. There is a change of uses of words in Sanskrit origin. So our test statistics Z equal to P minus P naught under root of PQ by N. So that test for proportion capital P equal to 0.15. So what is the value? Small p is x by n. What is x here? 17, 75 or 17, 17 by 75. So what we will get value? 17 by 70, 70, 17 by 76, 0.2267. So 0.2267 minus 0.15%, so 0.15. So here, this is x small p and this is capital P and this is P Q by N. Okay. So that value is what? 1.8594. So that calculated value, and which is what? To tell test. That value is 2.58, 1% level of significance. So calculated value is less than tabular value, so accept it not. So that is, so these are the exercise problems. Please be practice. So next, small order samples n greater than equal to 30 means 30 to infinity values comes under large sample. For that we have single proportion and single mean. And now small samples. In small samples we have less than or equal to 25. So from that also we need to explain, I need to explain single mean. So small sample test are TF chi-square called small sample test. Okay. Student T statistics, chi-square and F. These are small sample test. So large sample test for single mean also I explained. Now small sample test for single mean. So this is. So our statistics is here we can use small sample test for mean is T test. So our statistic is T. What does mean statistic? The sample observations of sampling distribution is known as the statistic. Here our statistic is T distribution, that is T minus expectation of T, standard error of T. So this is standard for just okay. So that is observe here. The parent population from which the sample is taken is a normal population. The given sample is a random sample. So the way the normal population is not known. Okay. So small test for so our not H1 is not. So subtraction to the population F is a sample and with n equal to dot by sigma by root 10. So here two cases. One is very known, that is what we compare. So next is variance in cost is not known. Rooted by value with the tabulated value corresponding kd minus degrees. Sigma is not. So here, so this is t equal to x power minus 2 s by root n minus 1. So this is small sample. So small sample singular. So assumptions made in sample test. The parent population from which sample is taken normal population. The given sample is a random sample. The variance of the normal population is not known. Okay. So small sample test for single mean is what here? I already told sigma is known, sigma is not known. So whatever may be. So if sigma is not known, we can use the s by root n minus 1. So iteration only sample variance s square equal to 1 by n summation xi minus x bar whole square, where s square equal to 1 by n minus 1 summation xi minus x bar whole square. The unbiased estimator of population variance sigma square, then the statistics t equal to x bar minus mu s by root n follows t distribution with n minus 1 degrees of freedom. So we that one fundamental property where expectation of s square equal to sigma square. In large sample it is okay, but in small sample which is expectation of s square not equal to sigma square, sample variance is not equal to sigma square. In that cases we can take s by root n minus 1. Okay, that is. So for that case, where s by root n minus 1, s by root n minus 1 is what here, the formula here is a very, very important ma. I want to tell you one thing. Small s square equal to 1 by n is summation xi minus x bar whole square is what? Small s square by n minus 1 equal to small n minus 1 s square by n. So then small s square equal to 1 minus 1 by n. For n tends to infinity, something by infinity 0. So that's why small s square equal to capital S square. But in case of small samples is n minus 1 by n capital S square. This is the formula. So that means what?
n small s square equal to n minus 1 s square. This is for small samples. Okay. This is for small samples. But in large samples is what? In large samples is what? Small s square. In large samples is what? Small s square equal to 1 minus 1 by n s square. This something by n tends to infinity 0. So small s square equal to capital S square. But in small samples is what? N s square equal to n minus 1 s square. This you please. In small sample we can take n s square equal to n minus 1 s square. So where here where here so where here so that is so here t equal to x bar minus mu by s by root n. So that is. So that is. So this is one example. What is the example? Here what I would like to say that here x bar minus mu naught s by root n minus 1. So is x bar minus mu naught s by root n minus 1 is nothing but s by root n. Okay, s by root n. So now I told you what is the difference of s by s and that. So what is here? S by root n minus 1. Nothing but s by root n. How? Instead of sample variance s square equal to 1 by n summation x minus x bar 4, we use s square equal to 1 by n minus summation x minus x bar whole square. So unbiased estimate of population variance sigma square. So then the test statistics is s by root n minus 1 is s by root n. Okay. So which follows t distribution n minus 1 degrees of freedom. S by root n minus 1 is nothing but S by root n. So this. So here one example. So here an example based on the sample normal distribution. The hypothesis mean is 65, variance is sigma square. So that is sigma square. Sample values is given how many? 3, 4, 5, 6, 7, 8, 9. So what is mean of population is 65. So mu naught level of significance 0.05. Our strategy is z equal to x bar minus mu naught by sigma by root n. Okay, where x sample is 65. Okay, population mean is 65. Where sample is what? Sample is what is given? Only sample observations is given. We have to calculate the means. Observations given, number of observations 68 points. So can you calculate sample mean? So can you calculate sample mean here? 62 plus Sounds so here sample x bar is what is the formula, sum of observations divided by number of observations. That means 22 plus 24 plus 67 plus 70 plus 68 plus 71 plus 75 plus overall observations is this. So observations 1, 2, 3, 7, 3, 4, 5, 6, 7, 8, 9, 10. So 688 by 10. So 68. So sample mean is 68.6 minus 65 by 4 by root 10. Is value is 3.002. So 5 level of significance is what here. So the value is calculated value is 3 is greater than tabular value. So reject H naught. So the conclusion is what value is that value. So it is more than, so otherwise we do not accept H naught. How accept H naught is what value is and 2.26. So accept H naught. Value is 0.0042. So tabular value is of 1.96. So 3 is greater than 1.96. So we reject H naught is greater than tabular value. So we reject H naught. Here claim is not equal to 65. So next one more problem. The sample observations whose mean is 58. So t equal to x bar minus mu s by root n minus 1. So here the sample observations whose total is 562 and x square is not given. Sample variance is not given, that we need to calculate sum of observations. So here that value is 31,695. So 56.2 minus 58 by 3.2496 by whole say 10 minus 1. So its value is 1.66. So tabulated value 5% level of significance is 2.262. So calculated value is less than tabular value. So we cannot reject H naught, means accept H naught. So here check your progress. So here what is a test one-sided or two-sided depends upon. So that is lot sample test where which is normal distribution is bell shaped. The observed sample point follows the left hand side of the region, that is left tail, and right hand side of the region is right tail test. Okay. So here, so these are the some problems. Please go through. These are the some model question examinations. So among these all, which is very, very important, the statistical hypothesis and single mean, single proportion, large sample, single mean are very, very important. Okay. So here statistical methods, one is estimation. Estimation. So what is the criteria of estimation? Unbiasedness, sufficiency, consistency, and efficiency. So it's very, very important. And estimation is, so next one is what? Next one is criteria of estimation. An estimator is satisfies all these conditions is called good estimator. What is which called good estimator? So which called good estimator. So which satisfies all conditions, that is called good estimator. Next, maximum likelihood estimation. An estimated likelihood function is what? The product of probability density function or probability mass function is called the f of xi comma theta is called the likelihood function. So that is called the likelihood function. So next one is Neyman-Pearson lemma, NP lemma. What is NP lemma? And which is the most powerful region that says the NP lemma? What is NP lemma? NP lemma shows that what is probability of type 1 error? Type 1 error. Reject H0 when H0 is true called type 1 error. What is alpha? What is alpha? What is alpha? Probability of type 1 error is probability of reject H0 when H0 is true. That is called the alpha. H0 is true. That is called the alpha. So next one is beta. What is beta? Accept H0 when H0 is true is called accept H0 when H naught is false, where H1 is true, is called the beta. So probability of type 1 error is known as level of significance, which is alpha level of significance, which is alpha is always fixed. That is 95% or 99%. Okay. So we have if given any distribution, we need to find type 1 error and type 2 error. Among those, some problems, minimum variance unbiased estimator. What does mean minimum variance unbiased estimator? What is minimum variance unbiased estimator? What is unbiased estimator? The sample mean is an unbiased estimator of population mean. But sample variance is not unbiased estimator of population variance. That is the fundamental properties. So please go through each and every chapter. If you have any doubts, I'll explain. Once again, please you go through the all model answers, small answers, small sample questions, long answer questions. Have you any doubt? I will explain. Please go through one by one. So here I'm sharing the notes from the beginning. What I explained, I am sharing now. So this theory of estimation, where main basic concepts of criteria of good estimator, Niemann-Pearson lemma, and method of movements, minimum variance unbiased estimator, and maximum likelihood estimator. So what are the measures of an estimator? Then estimator measures are method of movements, maximum likelihood estimation, minimum variance unbiased estimator. Okay, so one by one I have explained all. So basic of properties of good estimator, consistency, unbiased, and efficiency. Okay, so these are. So these some problems also I explained. These are very, very important. How the given statistic is consistent, how the given statistic is unbiased. These are the problems I explained. These are very, very important and very simple also. So next, so these are statistic is T, we need to show which is unbiased and which is consistent. That is. So this is model answers where explain the criteria of good estimator with suitable illustration. That means what are the criteria of estimator? Unbiasedness, consistency, sufficiency, efficiency. If an estimator is satisfied all these, then we can say that is called good estimator. So that we have to give the illustration. So one example you take, you have to prove all. There is the estimator to satisfy all these properties. So we need to prove that is efficient and it is also consistent and sufficient. So next one is what X2, etc. Xn, random sample observation from Bernoulli variable having the values with 0 and 1 with probability P, phi of n minus phi by n into n minus n and bad estimator of P square, where phi equal to x1 plus x2 plus n. Simple expectation of T, construction statistics T equal to so that is the have to take x1 to etc. Except. So to apply all these, we can get the formula. We can so get here. So next one estimator, maximum absolute estimate. So next one so next Neyman factorization theorem. Neyman factorization theorem shows efficient statistics. Here is the formula is that means where the sample observations are independent of theta is the sufficient statistic that explains Neyman theorem. Next of estimation, maximum likelihood, moments, and variance. What are the properties of likelihood estimate? Dou L by dou theta equal to 0. Dou square L by dou theta square is less than 0. So let the estimation order. And next one is what among these 1 to 3 units order properties and all these. And what I'm sharing that also. Questions. Test and test single mean. So these are I explained the 6 classes. So this chapter is finished. If you have any queries, let me know. Giving the time to you. If you have any queries, please mention in the chat box. Thank you, BRU, overview, giving this opportunity. Students, I am waiting in the room. Have you any doubts? Please let me know. So thank you, BROU team, for giving this opportunity. Students, let me know if you have any doubts of this paper. I will explain. Thank you.